Welcome students. Welcome to the final year of engineering, BE and TC. Today we are going to see the subject VLSI Design and Technology, and we will have an overview of VLSI Design and Technology subject of 2015 pattern, Savitribai Phule Pune University, Pune. What this subject is and what the teaching scheme and examination scheme given for this subject. This subject has 4 lectures, 4 hours per week. The examination scheme consisting of 30 marks in SEM and end SEM of 70 marks. The in SEM will be on the first 3 units and the 70 marks exam will be on all 6 units, in which the last 3 units will have more weightage and the first 3 units have a weightage of 20 marks. This subject has also a practical examination which is combined with the subject Lab Practice 2. The Lab Practice 2 is a combination of 2 subjects, Elective 1 and this VLSI Design and Technology. Quite obvious. Lab Practice 2 has 4 hours per week load of practical, out of which the 2 hours per week will be given to the VLSI Design and Technology. The combined practical examination will be of 50 marks and the term work will be also of 50 marks. The objectives of this course are to explore HDL. The long form of HDL is a hardware description language, and related design approach. Quite obvious, in this subject we will also study the CMOS circuit. Also we will go for the testability of these logic circuits and an overview of ASIC design issues. These things are in the course objective. What are the course outcomes of this? Quite obvious, there are 6 units, and corresponding to all these 6 units there will be the 6 course outcomes. Quite obvious, after completion of this course, student should able to, according to the first unit, you should able to write the HDL coding of given digital design. According to the second unit, you should able to understand or apply the knowledge of real-time design issues and digital design. The third unit is related to the PLDs. Quite obvious, you should able to model a digital circuit with HDL, able to simulate and synthesize a prototype on PLDs. The fourth unit is CMOS circuit design. That's why you should able to design a CMOS circuit. You should able to analyze various issues and constraint and design of ASICs, which is a 5th unit. And quite obvious, the last unit, that is the testability, you should able to apply the knowledge of testability and design and build self-test circuit. We will have an overview of what this subject contains. Actually, this subject has total 6 units. Here I will not read the syllabus point by point. Quite obvious, you have this syllabus available on unipune.ac.in. If you search on unipune.ac.in, you will find this syllabus. That's why I will have an overview of what this subject contains. This subject has a 6 different units, and there are certain names are being given to these units. If you see the unit number 1, which is a HDL design. HDL stands for hardware description language. What we are going to study in this particular unit is the design language, and the design language for a digital circuits, and that language is VHDL, that we are going to study over here. Quite obvious, we will study the design flow also. What are the different language construct, what are the different data objects, data types, what are the different modules which are essential in HDL design, such as entity, architecture and library. Similarly, Similarly, quite obvious, we will study the different sequential circuit, different concurrent circuits also, and we will write the statement related to it. There are certain things which are being supported by the HDLs, such as packages, subprograms, attributes, and also we will have a HDL modeling of combinational and sequential circuit. Means if you look towards unit number 1, this whole unit number 1 is associated with a language. Means in this unit number 1 you are going to study a language VHDL in much more detail. Unit 2 is related to the design, digital design and issues. Actually these are the issues. Means you can say that this unit is moreover devoted to the system on chip. System on chip means what? There are different issues when you combine all these things on a chip. If you combine all these things on the chip, so many things will come into the picture. The first issues, some issues related to the clock, some issues related to the power, some issues related to the wire parasites, some issues related to the I/O architectures. Means when you go for a digital design, all the things which are related to the putting everything on the chip, that is a system on chip, all the issues are being discussed in unit number 2. Unit number 3 is a PLD architecture and application. If you see a syllabus of this unit, you will come to know that there are different categories of PLDs, such as CPLD and FPGA. In your study, you have only these two things are being given. What you are going to study in this? Quite obvious, there will be a one particular CPLD from Xilinx family and one FPGA from Xilinx family. And for that FPGA and CPLD, we are going to study the architecture, feature and specification and application. Means this whole unit is being devoted to the PLD's architecture, features, specification and application. Quite obvious, this thing is essential when you implement anything on the PLD. PLD is mostly a reconfigurable hardware that we are going to see. If you see unit number 4, unit number 4 is a digital CMOS circuit. Actually, digital CMOS circuit is a thing that how when you implement anything, at last it will be implemented on any fabricated chip in the form of NMOS and PMOS. Quite obvious, if you implement anything in the form of NMOS and PMOS, you must know what are the different characteristics of NMOS and PMOS which are essential to study over here. Quite obvious, we are going for a CMOS implementation. Advantages which combines the advantages of NMOS as well as advantages of PMOS, and we will see the characteristic of this CMOS family in related to the digital design. Digital design means what? We are using NMOS and PMOS either on or off. Means quite obvious, here we are going to study the characteristic of these devices as on or off, and this include a best example, that is CMOS inverter. And quite obvious, we will study the power dissipation, power delay and some body effect, rise and fall time and also a transmission gate. Means after studying this unit, we are able to design a circuit with the help of transistors. This is the thing which we will study over here. The unit number 5 is a ASIC, application specific integrated circuit. In this we will see that actually this particular unit is also related to the you may say that semi-custom design flow. Semi-custom design flow means what? Actually you are going to implement a write an HDL and there will be the standard cell library, and with the help of standard cell library you are going to generate an ASIC, and there are different characteristic of this ASIC circuits. That's why quite obvious here you must go for a design flow. What do you mean by a cell design specification? How you can go for a spice simulation of this circuit? what is AC analysis, what is DC analysis. All these things you are going to study over here. Quite obvious, there will be lambda rule, then design rule check, what are the different fabrication method for circuit elements. Quite obvious, if in ASIC you are going to fabricate some component, and what is a cell design for NAND and NOR, what is a circuit extraction, what is the electrical rule check, how you can compare what was a layout generated and how was your schematic. That's why you will go for a layout versus schematic. These things you are going to study in unit number 5. Similarly, the last unit, that is a VLSI testing and analysis. Quite obvious, yet whatever the thing we have seen, everywhere you must test it. Does it is working or not? For everything it is different. If you are going for just take an example of writing a HDL code. If you write an HDL code, you must check that does your HDL code is working or not. For that you have simulation. With the help of simulation, you can check that does your HDL code is working or not. If you write you can directly use a simulator, or you can write HDL code, which is also called as a test bench. Similarly, if it is a fabrication, quite obvious, there will be a certain thing that how you can test a fabricated chip, and there will be the different methods to test this thing, and so many things will come into the picture, such as what is the testability, what is a fault model, what is a path sensitizing, what is the test pattern generation, how you can test a sequential circuit, and whatever the new advancement in testing, such as JTAG and boundary scan and tap controller. This is a total overview of what we are going to study in all these 6 units. Listen carefully. Actually, this particular thing contains 6 different units, and for each and everything you will find a different book in the library. Quite obvious, university has also specified the books. I will show you some of these books and the speciality of these books also. If you see that the books which are given in the university syllabus, these are, let us say, the first book, that is a Charles Ruth, Digital System Design using VHDL. So quite obvious, this book contained a unit number 1 only, and some part of unit number 6, testability. But most of the things, if you talk about the FPGA and CPLD, more thing might not be given, because this book is of HDL only. That's why you don't think that you will find all syllabus in one single book. Quite obvious, for every unit there will be the different books. That's why I will say that the first textbook will cover only unit number 1 and some part of unit number 6. If you take a second example of modern VLSI design, this is actually the if you see, this is a IP based design. There is another book also, that is a system on chip of the same author, and you will find unit number 2, most of the things which are being given over there in Wynne-Ulf's book. Similarly, if you take the example of third unit, then in third unit, which covers FPGA and CPLD, here you will find FPGA and CPLD in the most of the books. You can see the third book also, but better here I will suggest you that instead of using this book, you can directly refer to the data sheets which are available on Xilinx website for FPGA and CPLD. If you see the reference book which are given over here, the reference books are most related to the unit number 4 and 5. Unit number 4 is a digital CMOS VLSI. And you can see a very first book which is given in the reference list, that is the Neil Weste. That Neil Weste books contain a digital CMOS VLSI design and mostly used for unit number 4. Similarly, Becker's book, that is reference number 2, is also used for the same one. I will suggest the third book which is given in the list of reference, that is the Digital Design Principles and Practices. This book contains actually an overview of all the things, and this also contained HDL examples. This also contained the FSM design, which is some part of unit number 2 also. Like that, actually what I am going to refer, that also is very important. Actually, the book which is being not listed over here, is a simple book of J. Bhaskar. That is for language. You can refer the book of J. Bhaskar also to study the VHDL. I will time to time, when I will cover the units, at that time I will suggest you the books which are essential for this, other than this list also, if there is any book which is more important than this. I told initially that this subject has practicals, or this subject has practicals combined with lab practice 2. Okay, there are total 8 experiments. Out of all 8 are not compulsory. You can see that 7 experiments are compulsory, and there you can see 2 categories of this, A and B. If you see in A category, it is to write a VHDL code, simulate with test bed, synthesize and implement on PLD, and there are 5 options are given: a 4-bit ALU, a universal shift register, a FIFO memory, a LCD interface, and a keypad interface. Out of this 5, we can have any 4. We can go for any 4 experiments. And the B part, if you see carefully, it is to prepare a CMOS layout in selected technology, simulate with and without capacitive load, comment on rise and fall time. And here we have 3 different experiments: inverter, NAND, NOR, and 2:1 mux using logic gate and transmission gate, and single bit SRAM cell. Here just I will tell you one thing, why these 2 categories are over there, because for category A the software is different, and for category B the software is different. Category A content Xilinx ISE, and category B content a layout editor. We have a microwind layout editor in our college. I will explain one by one this experiment also later on when the lectures are being started. This is just an introduction to the experiment. That's why here I have shown you. The list you will also find in the university syllabus. Thank you.